Hello, fellow tech enthusiasts. Welcome to another one, How to Course from Cloud Expert Solution. In this course, we'll perform an end-to-end real-time database migration using AWS DMS. We have received this request from most of our friends and followers to create an in-depth course and demonstrate how to configure DMS, install AWS Schema Conversion Tool, and perform schema conversion for a heterogeneous database migration. In this demo, we will take a Microsoft SQL Server transactional database and perform the heterogeneous migration using AWS Database Migration Service or DMS and AWS Schema Conversion Tool. As part of housekeeping work, let's define who this course is for. If you have an organizational use case to migrate an on-premise database or a database from another cloud provider to AWS and you want to understand the end-to-end steps, if you have theoretical knowledge of AWS DMS and want to see how DMS works in action, because most of the AWS paid courses does not include DMS demonstration, or if you are preparing for AWS certification or job interview and need an in-depth understanding of AWS DMS and SCT or the schema conversion tool, then this course is for you. We believe this video will provide you the confidence to migrate a database of your own. You can also follow us for your organizational use case. Let's dive deep into today's topic and review the session outline. To ensure everyone is on the same page, we'll begin by covering the basic concepts of AWS Database Migration Service, AWS Schema Conversion Tool, and database migration on a high level. Following that, we'll dive deep into a 100% hands-on demonstration of real-time database migration, and here is a breakdown of what we'll cover. First, we'll configure the source database. Then we'll install and configure the AWS Schema Conversion Tool for heterogeneous migration. Then we'll discuss the action to take in case of schema conversion errors. Then we'll configure the target database, followed by we'll set up AWS DMS, including creating replication instances, DMS source and target endpoints, and the replication task. Then we'll perform the actual data migration and replication of any data changes. After that, we'll move on to module 3 to validate if the data migration was successful. In that module, we'll discuss different monitoring aspects such as CloudWatch metrics, DMS table statistics, DMS task logs, and DMS task status. Before concluding today's session, we'll clear the environment and resources to avoid any unexpected AWS charges. I hope you all are as excited as I am. This will be an information-filled session, so let's dive right into it. We'll start with database migration concept. Let's assume I have an on-premise data center where I have a transactional database. I want to migrate the database to a target database in AWS. You can have an Oracle database in your on-premise and you want to migrate to a Oracle database engine in AWS Cloud. Or you could have a Microsoft SQL Server database engine in on-prem and you want to migrate to Microsoft SQL Server in AWS Cloud. That means whatever the table, schemas, views, datas, and the stored procedures you are having in on-premise data centers, you can migrate as is to your target database in AWS. In our case, our source database engine equals to target database engine, and this type of migration is called homogeneous migration. But nowadays, with invention of cloud, most of the time you will find an use case where you will not perform a homogeneous migration. Homogeneous migration is very easy. You are not taking any extra care. You are just taking the data or the engine, doing a lift and shift and putting into AWS database or to a managed database offering. But as I was mentioning, you will have some use cases where you will have Oracle or SQL Server in your on-premise data center. And your organization wants to go to open source databases like PostgreSQL MySQL, MariaDB, or maybe from relational database to a non-relational database like DynamoDB. In this case, your source database engine and target database engine is not same, and this type of migration is called heterogeneous migration. Now, for both the migration, you do not need any expertise. You do not have to be a DBA and you do not have to understand each and everything of databases. Just you need basic understanding of database and how database works, or some basic knowledge about scripting, how to write scripts and data types in all those databases. Then you will be able to perform the database migration with the help of AWS DMS or Database Migration Service. Database Migration Service will take all the heavy lifting for you. And if you are performing a homogeneous migration, AWS DMS will take everything for you. On the other hand, for heterogeneous migration, you are considering that maybe you have to perform the schema conversion, right? The answer is absolutely no. AWS has a tool called Schema Conversion Tool, and it will take the heavy lifting from you. With a combination of AWS DMS and SCT or Schema Conversion Tool, you will be able to perform heterogeneous migration as well. Now let's review what are the source and what are the targets that AWS DMS supports. In the left hand side, we have our source database, and in terms of source, it could be Oracle, it could be Microsoft SQL Server, it could be MySQL, PostgreSQL, and when we are talking about Oracle, SQL Server, MySQL, PostgreSQL, this database can be in your on-premise VM, it can be with any other cloud provider, or it can be with AWS EC2 instance also. On the other hand, if you have some databases with Azure Cloud, it could be Azure SQL, it could be Azure Managed SQL, or it could be Azure Database for MySQL or PostgreSQL. DMS will support those also as a source database. Moving to GCP, it will support GCP SQL, GCP PostgreSQL, or the Cloud SQL database also as source. If your database in Oracle Cloud, then yes, it will support Oracle Cloud also. If you want to migrate away from SAP AES database, DMS supports that as well. If your database is in MongoDB, in on-premise data center Mongo Cloud, that will support. If your source database is Amazon Document DB, or could be Amazon S3, or even IBM DB2, AWS DMS supports a wide range of source, and you can see almost every type of databases it can support as a source database and move to any one of the target. It could be Oracle, MS SQL Server, MySQL, PostgreSQL, SAP AES. Now, when you are talking about this, you can host those into EC2 instance, or you can use Amazon RDS to host Oracle, MySQL, SQL Server, and PostgreSQL. You can also migrate to Amazon Redshift, that is a data warehouse. You can go to Amazon DynamoDB, Amazon S3, Amazon Kinesis Data Stream, Amazon OpenSearch, Amazon Document DB, Amazon Neptune, Amazon Timestamp, Amazon Babelfish, and last but not least, Redis. So you can see in terms of target, it supports a wide range of target. Now the next question is, let's say your database is in AWS Cloud. Will you be able to take it out from AWS using DMS? The answer is yes, not for all databases. And if you see, DynamoDB, that is not available as DMS source. So if your source database is DynamoDB, then you won't be able to use DMS for DynamoDB migration. But if your database is in EC2 instance, if you are maintaining an Oracle, SQL Server or MySQL, or if you are in Amazon Document DB, then yes, you will be able to use AWS DMS to take it out of AWS. And if you are performing heterogeneous migration, in that case, please remember to use Schema Conversion Tool along with AWS DMS. Now, in terms of migration modes, we have two different modes. The option one, we can take a database backup, and then we can ship the backup to AWS and we can recreate the database using the backup. This mode is called offline migration. But most of your use case, you will not see that migration. because you will have some application and that will constantly read and write data to your transactional database. To do this kind of migration, you need to shut down your application. And most of the cases that is not possible. To support that kind of use cases, we can use online migration. That means while the application is accessing your transactional data, writing the data, DMS will be able to replicate all the data and perform the database migration without impacting your application performance. This type of migration we call as online migration. And DMS supports both types of migration. Before we proceed further, I would like to request you, if you are new to our channel or haven't subscribed yet, then please consider subscribing to our channel and please click on the bell icon to get notification for any new topic. We upload videos on various cloud topics frequently. Now let's continue. For today's lab, we are going to use the setup as follows. For source database, we are going to use an Amazon EC2 instance. And as I mentioned, we are going to use Microsoft SQL Server as our transactional database. That database will have some transactional data. It's not an empty database. That is how we'll show you the schema conversion, the data conversion, everything in action. As part of target database, we are going to use Amazon Aurora MySQL engine because we want to perform a heterogeneous migration. As I mentioned, homogeneous migration is easy. That is why we want to tackle the difficult use case. We are going to use AWS DMS for online migration. As in the previous slide, we saw offline migration, just take the backup and ship it. We are not going to perform that. And we are going to use DMS plus schema conversion tool to convert the Microsoft SQL Server schema to MySQL schema. Now you might be thinking that your database or your organizational use case has a database in on-premise server. But for my demo, I am using an EC2 instance. Then it is hell and heaven difference. The answer is no. Because we are going to use EC2 public IP or public DNS to connect with DMS. We are not going to use AWS localized setting or local host or anything. We are going to use EC2 public IP. For your organizational use case, you will use the public IP of the database server while connecting or configuring the source. Then we are going to use Microsoft SQL Server Management Studio to connect to the MS SQL database or the source database. Now you can use the same thing in your on-premise database. We are going to use MS SQL Workbench 8.0 CE version to connect Aurora MySQL Target DB. Again, you can use the MySQL Workbench. It is not specific to any AWS tool. You can install in your on-premise database or in on-premise server to validate the target database. Then we are going to install the AWS SCT or the schema conversion tool in our EC2 instance. You are going to install in your on-premise VM or into the database server. Please remember the SCT should be installed into the source database server where you have the database. And one important point for this entire demo, to use AWS DMS, you really do not need a VPN connection or direct connect. We are going to use public IPs or the public internet connection to migrate the data. If you have secret data and if your organizational compliance requirement restrict you that you cannot go to public internet, in that case, you may use a VPN or direct connect. But having a VPN connection or direct connect connection is not a mandatory requirement to migrate your data or to migrate the schema using DMS and SCT. Now let's see everything in action. From this point, I'll move to AWS Management Console and let's continue there. I have logged into AWS Management Console and I am at console home. First, I'll go to EC2 dashboard. If you have access EC2, you can see in recently visited, or else type EC2 from the search bar. And here is my EC2 instance. My source database is running in this EC2 instance, and then my target database is Amazon Aurora. So I'll go to my target database engine. For that, I'll go to RDS because Aurora is the engine of RDS. For this lab, I have already created the target database where I am going to migrate the SQL Server database. And this is my target database where I have a Aurora MySQL cluster. I'll go back to EC2. I'll connect into the EC2 instance and then I'll come back. I have connected to the EC2 instance using remote desktop connection. Next, I'll try to access the SQL Server Management Studio. For that, I'll go to Start menu, and then I have Microsoft SQL Server is pre-installed in that. And I believe if you have a SQL Server, you should have Microsoft SQL Server pre-installed there, from where you can access the SQL Server and prepare the database as source for the DMS. I'll connect to the SQL Server Management Studio. I'll use the default option. I'll use Windows Authentication and connect. So this is the sample database that we have created for this database migration. And I am going to use this database as a source database for our DMS migration. The next step is we have to prepare the database as source for the DMS. And for that, I'll open the SQL Server Management Studio query editor. And there I am going to run some queries. To prepare this database as source database for DMS, I have already created the script. I'll provide the GitLab link where I have placed all those scripts, configuration, and step-by-step processes you can use for your use case. Now let's try to explain what we are going to do. First, we are setting the master as the database context. Then we are going to alter the server role here, and then we are going to alter the database because we are trying to set the recovery model to full for DMS sample. Then we are configuring the SQL Server as its own distributor. Now, when we are trying to access this database, this is my password. I have used password 1. You have to use your password or whatever the password you have used for that. And then for the replication source, here is the section where I am configuring the replication. And what I'm trying to do, I'm trying to access the sys object. If it's not exist, I'll create a sys object. And then I'm going to set all those parameters. Now let's execute that script. I'll select the entire script and I'll execute. Okay, the script has been successfully executed. Now my source database is fully prepared as a DMS source. Next, I have to configure the target database. I'll minimize the SQL Server Management Studio. Now first, we have to install the Schema Conversion Tool. I'll go to Google and there I'll access AWS Schema Conversion Tool. I'll come to the second URL, Schema Conversion Tool User Guide. And the second from the left-hand side menu, installing, verifying, and updating. Now at the middle of the screen, you have installing AWS SCT or Schema Conversion Tool. Now you can see here are the installer for the Schema Conversion Tool. If you are accessing using a Microsoft Windows, you can download the Windows Schema Conversion Tool downloader. If you are using Ubuntu or Fedora, you can select the according installer for your operating system. Now I will use Microsoft Windows. If I'll click, it will start downloading. The Schema Conversion Tool started downloading in my EC2 instance. I'll allow that tool to be downloaded. Okay. The download process has been completed. I'll go inside the download folder. I'll unzip it. Unzipped process completed successfully. I'll go inside the downloaded folder. And there I have Schema Conversion Tool installer. I'll double click on that installer and I'll follow the step-by-step processes as it will come into the screen. Okay, installation process completed successfully. I'll click finish. Then I'll close this pop-up and also the AWS documentation. AWS Schema Conversion Tool shortcut has been created to my desktop. If it's not created by default, you can go to Start menu and there you can access AWS Schema Conversion Tool. I'll accept the term. Schema Conversion Tool is ready for the configuration. Before configuring the attributes in AWS SCT, we need to configure our target database. Let's configure the target database in MySQL Workbench first, then we'll resume the configuration in AWS SCT. I will add a new connection. I will use the connection name as Target Aurora RDS MySQL. You can choose whatever name you want. For host name, I need the Aurora MySQL writer endpoint. I'll copy the writer endpoint from the Aurora cluster. Now I'll go inside that cluster. I'll copy the writer instance endpoint. I'll go back to my EC2 instance. And for the host name, instead of 172, I'll provide the host name of my MySQL writer instance. Then port, it will be same. And here I have a username. Next, I'll use the username, and I have used username as dbmaster for my test connection. Please use whatever the username is applicable for you or what you are going to create. Next, I'm going to provide the password, and I'm going to store the password into Vault. So I'll provide the password. I'll click OK, and then I'm going to initiate a test connection. Yes, for me, successfully made connection to MySQL target database. I'll click OK. I'll click OK. I'll keep the default schema as blank, and I'll click OK. Here you go. It has created a MySQL connection for us. Then the next step is I'll initiate connection to my target database, and I'll execute some script to provide permissions such that Schema Conversion Tool can write the data into the target database. So I'll click on the target database. It will open a query editor for me. I am going to copy a script that will provide all the required permissions for the AWS SCT tool to write the schema to the target database using the database username. As I mentioned earlier, I will provide the GitLab repo URL in the video description. Please make sure that you have replaced the database username before executing that script. Before I'll execute, let me show you. I have provided grant create on, then grant alter, drop, index, all those DB related activities. And also behind the scene, it will use AWS Lambda. That is why I have given the permission for AWS Lambda access also. Now I'll select all those scripts and I'll click on execute. All the script executed successfully. Now next, I'm going to minimize this MySQL workbench and I'll resume from the Schema Conversion Tool. First, the project name. I'll try to change the project name to something meaningful. Maybe I'll use source DB MS SQL target DB Aurora MySQL. Location, maybe I'll go with the default option, and then it's a SQL Server database. Source engine, I'm going to select the source database from here. I'll select Microsoft SQL Server. I'll go with the option I want to switch engine and optimize the cloud. Then I'll go to next. Then I'm going to connect to the source database. Connection name, I'll provide MS SQL Server because this is the MS SQL Server. For server name, I'm going to use localhost because my database is in the same EC2 instance. That is why I'm going to use localhost. Server port 1433, default SQL Server port. Now instance name, again localhost. For authentication, I can use Windows authentication or SQL Server authentication. Let's use the SQL Server authentication, and I will use the username what you have to log into the database. I'm going to store the password. Now next we have to use the SQL Server driver path. So I'll browse, and my SQL Server driver path is available in the desktop. I'll use the first jar, MySQL JDBC 7.4.1 JRE8.jar. Please select the proper SQL Server driver path for your use case. And now I'm going to initiate a test connection. I'll use accept risk and continue. Okay, connection is successful. I'll go next. If you see this warning, because I haven't configured SSL, if you want for your organizational use case to configure SSL, you can do that. but I will accept the risk and I'll continue. Now next I have to choose the schema. Here I have all those schema. I'm going to select the DMS sample schema and I'm going to click next. Behind the scene, Schema Conversion Tool is performing a migration assessment, and once it will be completed, it will provide database migration assessment report. It will take a couple of minutes for the assessment to be completed. Okay, the assessment has been completed successfully, and you can see the assessment report here. Schema Conversion Tool assesses your source database and it is coming with recommendation what will be the best fit for your target database. Now you can see here I have the store object, code object, conversion actions, the compatibility and all. So you can see the MySQL compatibility, PostgreSQL compatibility. If you come below, Amazon Redshift. If I come further bottom to this assessment report, then you can see the conversion statistics for database object. How many schemas, how many table, how many constant, how many indexes. It has provided all those details here. And with color code, object automatically converted, object with medium complexity action, and object with complex action. So I can see that object with simple action, the dark green, it is 100%. Object with automatically converted, the light green, it is also, and there is 6% object with complex actions. Now this is the detailed analysis report. You can review. If you want, either you can save as a PDF. Let me save in my desktop such that I can review offline, and also you can export as a CSV. I'm going to click next, and then I have to select the target database. For target engine, I am going to use Amazon RDS for MySQL. Connection name, I'll provide DMS demo Aurora MySQL target. For the server name, again I'll go to my Aurora database and I am going to select this endpoint, whatever the endpoint we have used for the MySQL workbench. I'll copy this endpoint. I'll use, this is a server name. For MySQL, server port would be 3306. Now username, please use the username what you have for your database. I'll use the password. I'll store the password. Then I have to select the MySQL driver path. I have the driver in my desktop. Now you can select wherever you have stored the driver. I'll go to browse and MySQL connector. That is my MySQL driver path. I'll select. I'll perform a test connection. I'll accept the risk. Connection successful, and then finish. Again, I'll accept the risk. I have successfully established my source database and target database for SCT. Now, if I want, I can go to main view and I can see the assessment report, what we discussed in the previous stage. This is my source database, Microsoft SQL Server DMS sample. This is my schema. I'll select the schema. I'll go to main view and then I'll select the assessment report. This assessment report we have already seen. I'll go to the action item tab from here. In the action tab, you will see two different colors, one with the green, and then if you'll come at the bottom, you have with blues. Now AWS SCT analyzes the schema and creates a database migration assessment report for this conversion. Each item with this blue mark, SCT cannot directly translate from source to the target. However, the items in the green, SCT will translate directly from source to target. Now we have two options. For all those items in the blues, either we can modify the object on the source database so that AWS SCT can convert the object for the target, or else once SCT will generate all those database script, we can go ahead and apply the fix there. So there are the two options. But before that, let's try to understand what kind of issue it is getting. If I'll go to this issue, MySQL does not support round function with the function argument. That means in your Microsoft SQL Server, there are some procedures with round function. Also, unable to convert object. You can see number of object RDS deny backup trigger, database trigger. This is the trigger, unable to convert object of the database trigger category. We have some stored procedures, create diagram and transform error occur in this statement. That means internal conversion error occur. So now, as I mentioned, I have two options. Either I can go ahead and update the source database. That is not the case for most of your use case. You cannot go ahead and update the source. That is going to break maybe your all those applications. But we can try to fix those when the script will be generated. Now, every use case is different. Based on your finding, you have to go ahead and take the corresponding steps. But for this demo, since I cannot cover all the different use cases available in the market, I am going to skip. But please make sure that you have fixed or take the necessary action what is applicable for you. I am going to select my sample and I am going to right click. Here you can see the create report and convert schema. I am going to convert this schema. It is saying this object might already exist in the target database. Do you want to replace? I am going to say yes. This is your source schema and this is your target schema. I am going to right click on DMS sample DBO and I am going to apply to database. I'll select yes. Now at this time, all those changes or the schema conversion is going to be applied to the target database. The schema has been applied to the target database. I can go and expand the sample schema. And here, if I'll go, I can see all those tables where I have the tables here in that source database. All those tables automatically converted into MySQL. From MS SQL, it has converted to MySQL. We have completed the first part of the demo where we have taken a Microsoft SQL database and automatically converted the schema for MySQL database. If you have a different source and different target, the basic steps will be identical, but you have to choose corresponding DB port and the driver. The next part would be the data migration. I'm going to minimize the schema conversion tool for the time being. I don't need the schema conversion report. I'm going to open the MySQL workbench. I'm going to close this query. In this step, the first what we are going to do, we are going to drop the foreign key constraint from the target database. That is why again, I'll connect to my target database. The reason for dropping the foreign keys from the target database is to ensure that the data copy process is not affected by any constraints. As you know, if there are any foreign key relationship between two tables, then data must be uploaded in the proper order. Since DMS will copy all the records in parallel, any constraint may create a blocker. If you skip this step, you may encounter data copy errors in your DMS execution logs. This script is specific to my DB schema, so I'll not provide this script in the GitLab repo. Your DB schema will have different DB objects and relationships. This script is simply alter the table and drop the foreign keys. I'll select all the script and it is going to delete the index and the foreign key. So I'm going to drop all those indexes and those foreign keys. Please make sure that you are not dropping from the source, but we are dropping from the target. I'm going to execute. It has dropped all those indexes and foreign keys. Now I'll navigate to my AWS Management Console and I'll go to DMS dashboard, Database Migration Service. Now from the DMS dashboard, left-hand side, I have migrate data and I have replication instance. I'll click the replication instances. I already have one replication instances that is available, but let me show you how to create a replication instance. I'll create replication instance. I'll provide the name as DMS Demo Lab. Description, it is optional. I can keep it blank. For the instances, instance class, now let's select, instead of T3 medium, I'll take C5 extra large. For engine version, I'll select the highest available version. Allocated storage, I'll go with the default option 50 GB. For the connectivity, I'll use the IPv4. For the VPC, I already have these available VPCs. Now you can select what VPC you want to place. I'm going to use DMS Demo Lab. This is the VPC that I have created. This is the replication subnet group. I'm okay with that. One important factor, for security reason, I don't want this instance to be publicly accessible. When you are going to migrate your enterprise data, please make sure that you uncheck this public accessible option. And then I'm going to create replication instance. Okay, for the high availability, for your production workload, please choose the production workload multi-AZ. For me, I'll choose the dev or test workload. I don't want to incur a good amount of fee here. That is why I want to use dev or test. But please use based on your use case. If you are doing your enterprise migration, please choose the production. But if you do not want the high availability for the DMS option only, go ahead and choose the dev and test. I'll create replication instance. Okay, the replication instance creation process has been started. It can take several minutes. I will pause the video here and I will come back when the creation process will be completed successfully. It took around 10 minutes to create the replication instance. Now let's create the source and the target endpoints. To create endpoints, let's click the endpoint option from the left panel under migration data. We'll start with the source endpoint creation process. For our demo, source database is Microsoft SQL Server. I'll click create endpoint, source endpoint, endpoint identifier. Maybe I'll use MS SQL Server source because I want to distinguish what is my source endpoint and what is my target endpoint. Description optional and I can keep it blank. From source engine drop down, since I am going to use Microsoft SQL Server, that is why I will use Microsoft SQL Server as my source database. Now I have to provide the access credentials details. Using that credential, source database will be accessed. If you have used AWS Secrets Manager to store the DB credentials, which is very unlikely for on-premise source database, and I do not have my DB secrets configured in AWS Secret Manager, so I will enter manually. But the best practice is to use AWS Secret Manager for any secrets or DB credentials and provide the ARN of the secrets for the AWS resources. I will select the second option to enter the access information manually. In server name, if you remember that I am hosting the server in EC2 instance, that is why I will use the EC2 instance public DNS name. But if you are using on-premise server, please use the server name for the on-premise database server. I'll go to my EC2 instance. I'll select that EC2 instance and I'll copy the public DNS, public IPv4 DNS. I'll provide the DNS in my server name. For port, it will be default port 1433 because I am going to use Microsoft SQL Server. Username, please provide the username that is applicable for you. Since I am not using SSL, I'll select this as none. For database name, I'm going to provide DMS _ sample, and then I'm going to move to test connection. VPC is by default selected, and then I'm going to use the replication instance, and I'm going to run a test. Please pay attention to this warning message. Endpoint will be created even if the connection is failed. Now let's try to test the connection first. Okay, now it is testing. Let's wait for the testing to be completed. The test connection is successful. Now I'll create the endpoint. Okay, here is my source endpoint. Now next, I am going to create a target endpoint. This time I'll select the target endpoint and endpoint identifier. Maybe I can use Aurora MySQL target. Again, I'll put the description as blank. I'll choose the engine as Aurora MySQL, Amazon Aurora MySQL. Again, I will use the information manually. Now server name, I have to go to my MySQL Aurora. I'll go to the databases. I'll copy the Aurora MySQL writer instance endpoint. I'll go back to DMS endpoint configuration console and use as server name for the target endpoint. For MySQL, default port is 3306. I'll use the username and password. Please provide the username and password that is applicable for you. And again, I'm going to test the connection. So this time I'll perform run test. Similar process, whatever we have followed for source database. Okay. Connection to the target database is successful. I'll create the endpoint. Here is my target and here is my source. So these are the endpoints that I have created. Please ignore the third one, that was I was testing before this lab. We have created the replication instance. Now it is available. We have created the endpoint. Next, we have to create the database migration task. So I'll go to database migration task and I'll create the task. Task identifier, we have to provide an unique identifier. I'll use MS SQL source to Aurora MySQL target. The replication resource ARN, that is optional. I am going to choose the replication instance. I'll use DMS demo lab. I'll use the source endpoint, whatever we have created. So I'll use MySQL source and the target endpoint. Moving to migration type, either we can migrate the existing data or we can migrate the existing data and replicate the ongoing changes. I believe for your production, you want to migrate the existing data along with any delta that may create or modify while the migration is going on. Let's select the second option, that is the option to migrate the existing data and replicate the ongoing changes. Now for my task setting, I'll use the wizard mode. I don't want to go in a JSON editor mode. Custom CDC stop, I'll go with the default option. Target table preparation mode, I'll select do nothing because I have used Schema Conversion Tool and I have already migrated that schema. If you are going to drop table on target, then it is going to drop everything and it is going to create. That is applicable only for homogeneous migration. Since I am doing a heterogeneous migration and I have created the schema using SCT, that is why I am going to use do nothing. For stop behavior or stop task after full load completes, I'll select don't stop, as I want to capture the delta and I need change data capture or CDC feature. Other features, I'll select the default option. Next, task log. It's very important for debugging any migration issue. Let's enable the CloudWatch log. I'll scroll further bottom of the screen. For table mapping, I'll select the wizard mode for the editing. I'm going to add a new selection rule. I have to provide the schema name here. Now enter a schema. I'll select source schema. I'll use DBO because for SQL Server, I have that schema name as DBO. If you remember, if I'll go to SCT, I have that schema as DBO. Source table, I want to replicate everything. That is why I will use wildcard character. For the transformation rule, I'll select the default option. I have already completed the pre-migration assessment using Schema Conversion Tool. That is why I'm going to skip this. I'm going to untick this and I'm going to create task. My database migration task creation process is in progress. I will allow the status to turn starting. The status has been updated from created to starting. That means the task is connecting to the replication instance and to the source and target endpoints. I'll wait for the status to turn running. Here is the process meter to indicate the percentage of completion and it will be populated once the task will turn to running status. We are performing a full load with ongoing replication. These are the source and the target endpoints that we have created for the source and the target databases. It took around 60 to 70 seconds. Now the migration task is in running status and the completion percentage is 4%. I can click on this identifier hyperlink and I'll be able to see the progress here. This is the progress. This is the table statistics. You can see this is the schema, the DBO schema, the table name, and you will be able to see the table wise details. full load rows, total rows, and everything, all the statistics you can see here. Now this is the CloudWatch metrics. It may take some time to populate those metrics, mapping rules. And if you remember that we have disabled that pre-migration assessment, that is why nothing will be here. Maybe I'll go one level up. Now it is 12%. The migration completion time will vary based on the data volume, network speed, number of objects to be migrated, type and destination of source data, etc. etc. As a result, migration completion time may vary for you. While the migration process is running, let's review the possible migration status and what is the meaning of every status. These statuses are straight from AWS documentation. We have seen the creating status. That means AWS DMS was creating the task. Next, the running status. What is our current status? Which means DMS is performing the migration. And then here are all other statuses and the name is self-explanatory. Since we are using full replication with CDC, for our migration process, once the migration will be completed, we will see a status load completed, replication ongoing. I'll wait for some more time and monitor for any errors that may occur. Currently, the status is running and in green. That means the migration process is running without any error. When the process will encounter any error, then the color will change from green to red. If you see any error, you have to go to CloudWatch log to check the exact error you have received. Let me take you to CloudWatch and let's review the execution logs together. At the service search bar, I'll type CloudWatch and then I'll select CloudWatch. I'll go to logs, then log groups. Here is the log stream. Here is the execution logs with all the details. You can check the specific log lines. I don't have any error in this migration process till now. That is why no error trace is here for my case. But if you see any error, these execution logs are very helpful to get insights about the error. I'll go back to my DMS screen and I'll continue to monitor for any error. I had a standard transactional database with 10 to 15 GB of data. The migration process ran closely 20 minutes for me. As I told earlier, the migration time is subjective and will depend on the multiple factors. We discussed those factors previously. Now the migration process completed successfully and the status is load completed and replication ongoing. This status is only available for data migration with full load and change data capture. And DMS is currently working on the delta part or any change or update on the DB activities while the migration was in progress. Currently, no application is writing data to my source database and I don't expect much delta available. But I'll keep it running for some more times. Since DMS has successfully migrated all the data from my source to my target database, now it's time to inspect the content and let's see if all the data has been migrated to the target database or not. And to do that, I'll go back to my EC2 instance where I have MySQL Workbench installed. I'll click on the target Aurora database. I'll double click that. And if you remember the DBO schema, I have the tables here. Now let's try to see what are the data that has been migrated. Before that, I'll go to source database and let's see what are the source data we have. I will select the sporting event table and I'll select top 1000 rows from the table. The query pulled some data from the table. Yes, it's pulled 1000 records from the table. Now let's remove the top 1000 clause from the query and pull all the records and let's see how many rows it returns. I think some error in the query. I'll fix it and I'll execute again. Okay. It has total 1158 rows. Let's execute the same steps in our target database. I'll select the sporting event table and I'll select 1000 rows. The query returned 1000 rows. Oops, I re-executed the same query again. Now let's change the limit from 1000 to 2000 rows and let's execute again. This time it's retrieved 1158 rows, exactly same as in my source DB. That means all the data from the sporting table migrated successfully. I'll check one more table. Validation is very important. I'll select sport type table and let's pull top 1000 rows. This table has only 2 rows and sport types as baseball and football. I'll go to my target database and perform the same steps. Here you go. We got the exactly same result. I am good with my validation, but for your case, you can perform further validations to tally the source DB content and target database content before terminating the replication. If you remember, before the migration, we dropped all the indexes and foreign key relationships from the target database such that DMS can copy the data freely. Now it's time to recreate them again. I already have a script for that. Again, this script is tightly coupled with my database schema and it won't work with your target database. That is why I won't provide this script as well. It's very simple SQL script to add the foreign key constants what we removed earlier. I'll select all the queries and I will execute. Before we conclude today's video, let me show you all those migration monitoring steps, how you can monitor all those migration, and if you see there is any error, how you can monitor those errors and how you can troubleshoot. So I will go away from this EC2 instance and I'll go to my DMS screen. I'll select the migration task and I can go to CloudWatch metrics. Here I can see a full load throughput bandwidth target, full load throughput rows target. These are some of the metrics. I can also go to the replication instance. I have used DMS demo. That is why I can go inside that instance. And here I can go to my CloudWatch metrics. Here I have the CPU utilization, freeable memory, free memory utilization, available memory, free storage space, write latency, read latency. I have all those metrics and charts. If you see a consistent spike here and migration is stalled for a longer time and the percentage is not increasing, then you can consider replacing the migration instance with higher capacity. You can go to the migration task. We were monitoring the table statistics. This is your table-wise statistics where how much time it elapsed. If you want, you can export into a CSV file. If you want to check the task log, you can go to CloudWatch. We have already seen the task log. This is my task log. It has the detailed logs based on whatever it is performing. And also the last but not least, the task status. So if I'll go again here, here is the task. It's still trying to replicate the delta. As I mentioned earlier, currently no application is accessing my source database and I don't expect constant data changes in my source database. For your case, when it's time to cut over, that means when all the synchronization will be completed between the source and the target database, you can stop the replication. To stop replication, select the task, go to action, and then stop. Let me refresh the task. The status is stopping. It may take 30 seconds for the process to be completed and the task status turn to stopped. It stopped successfully. Once everything is done, you should clean your environment or else you will end up paying for EC2 instance charges what we have configured for the replication instance. Let's first terminate the replication instance. I'll keep one for a different video, but I can terminate one. I'll select the instance and then from the action drop down, I'll select delete. It's deleting now. As part of this lab, if you have created any EC2 instance to host the database, It's best practice to terminate that also if you don't need it. But for my case, I need for a different demo. That is why I will keep that EC2 instance for me. That was all for today. I hope you have learned the end-to-end database migration process and I was able to provide you the necessary details and knowledge to handle any real-life database migration use case. If you still have any doubt, please drop your query, question, or request for any new topics as comment to this video. If you like our effort, please give us a thumbs up and please share this video with your friends and families. Subscribe to our channel and please click on the bell icon for more content like this. Thank you for watching.